forming, and I'm discovering, and I'm also packaging. And I think it's important to have a good objective look how manufacturing can change in the future, and how also we can be part of it, because most of the time it is something that we say, well, other people will do, and we give the problem to the others. Now, we could certainly do that, but we could also be responsible and take responsibility and say, hey, if I can change a little bit in my sector, if I can improve my production, then, if I can go a little deeper, then I think we're all going to be onto something. And although everybody thinks that manufacturing is about creating beautiful object, well, manufacturing is about making, you know, the same object repetitively at the same quality. And additive manufacturing is something that can help that process to accelerate. As an example, when I design a product, I make a prototype. And then the prototype, for me, is a proof to see how the possibility are are there, how the proof of concept. I bring it to my clients and I have them approve, and I tell them, well, we can change this, we can change that, and after a few changes, I'll start charging. But most of all, it's something that came out of my mind in the physical world, and that's what empower me. And this is the passion, and this is the vision that I want my turn empower you, so that your ideas can become product, and then, as time go, you can start producing them and get maybe royalty, or sell them and have the whole everything that goes with it, or just support the local manufacturing with products that are high quality. We are in a very, very particular time right now, and that's the beauty of being at this time, because we're celebrating everywhere you look, aerospace, manufacturing, marine industry, medical, computers, AI. We're celebrating innovation, and innovation is a very important part. But manufacturing survive through repeatability, and as far as often that we can repeat these motion and create something consistently, the more we can start to make complicated things more intricate, more sophisticated, enhance on the finishes, enhance on the speed, enhance the material. So it's all tangled together, and it all start here. It all start with something that you need. And I'm sure that you've seen a product that at one time you were really, really impressed, and now it's like, well, that's easy. We do this like day in, day out. And this is where I think additive manufacturing can help us to go ahead and move forward, because none before we had opportunity to manufacture at that speed. None before we had opportunity to manufacture a, a wide array of material in a short delay, in a very short process. Meaning that in the past you needed to have big stamping press, you needed to have long line of production, you needed to have different items, different tools to make holes and threads and this. And now all these can be done in one process. I'm not saying that it's perfect yet, but from the past 15 years, it went from there to there. And now it's tweaking. And the more we're going to start using it and developing and creating with it, the more will bring the challenge to the manufacturers, and the more they'll be able to solve them, and the more we'll become more efficient. So as a creator, and what's our role? Well, as a creator, our role is to take object and bring them to life. And then there's some technician that takes that and then they create a drawing, and then they use different machines, and then they make it. They make the machine comes with a physical universe product, and after that they give it back to us, and we look at it and we tell our tweaking, and they fix it. So it is a constant um, collaboration between different people, and then once it's done, it's duplicatable uh, to the infinite. You can send the file to your neighbor, you can send the file to your club, you can send the file to 1,000 machine, and unlike um, physical machine, they don't wear out. File don't wear out. The machine may wear out, but the file doesn't. And the same level of precision that you have made it with will be duplicate and duplicate and done at different by different machine in different area. So we are really assisting into a decentralized manufacturing revolution that's driven by digital. And now we have the force of AI that can help our production, like monitoring, quality control, and like also optimization, and on and on and on. And all those things, what they do is they improve the process. They reduce the procurement pressure, because before we had to go through a long process of preparation. Let's say you needed a mold for a 30-ton press. The mold could have been take 2, 3, 4 months to do. And God forbid you didn't forget anything, or you didn't want to make any change, because that was it. That was another mold and another this. So the timeline shortened dramatically. Now, same thing with material. In the past, we had, let's say you do a mold for a certain type of material. Don't try to do something else with it, because then, it's going to damage it. Now, since we're working with different additive process, I can take the same file and print it in different material in the same time. Well, not the same time. Maybe some material will take longer, but I don't need to go through having all these different change. Uh, Supplier is the same thing. In the past, we had to have all these suppliers giving us material and waiting, and then they would get material from others and this and that. Now it is very streaming. And I think with the future, we will start to see more and more recycling of product, and manufacturing of the filaments, manufacturing of the powder, manufacturing of the different resin and liquid, and so that we can have an integrated uh, fabrication line in a very very efficient way. The other thing that I really like is that once you calibrate a machine, once you know the how the machine works, and you have the right tolerance and everything, it is very, very simple, and it goes. And let's say and it happened to me recently. I was making a model, and I didn't need all the support necessary because it was mostly an aesthetical part more than a physical. Um, there was no tension or anything that needed mechanical support, so it was just aesthetic. So the computer optimized, and we managed to save half of the material and half of the time to build that product. So again, like shortcuts and all of that is part of the development. And as we're gonna become more efficient and more professional about it, and more educated, and everybody's gonna start to communicate and collaborate, we'll become more and more efficient. um, well, it's the same thing, and it's funny because right now I'm working on a project for a training center, and I was designing, and people challenge me. They say, why do you have all these different stations? I said, first of all, what I want to set up in the training center is different area so that it can act as an overall factory, and we can have different zone. I don't want to have machines and computer all tied into one computer, and people in other part of the chain will be stopped because somebody else is modifying something. So every part has its own control, every part has its own computer, all those computers are tied into a network. And if there's machines that are not used, then they can be optimized, used by another department, and on and on. And the way to think is so different, because in the past it was almost inconceivable to go into another department and use different material. As an example, if you had an area of your shop that was doing stainless steel, well, you couldn't do regular steel or aluminum in that shop. So let's say you had a very low production of stainless steel, you used 20% of your machine, the other machine you couldn't use them. Now with 3D printing, I could use the machine to do different function, and every area has different type of machine, so that if I need to do a big production of a certain material, I can load them all up and go and do it. And the setup is not going to change anything or contaminate, because most of those systems, when we talk about metals and all those high metal and high technology laser machine, we're talking, they're enclosed system. So once we clean them, once they did the cycle, whatever we load in, they're going to be able to do it. And normally it's pretty fast, because the process that has been taught through to be able to do different material. So now we have different part of the factory that can all be doing at all ends and printing everything together, or we can have different area printing different parts. And the same thing for the environment. Like the if we have, let's say we're finishing a type of part, well, now the parts are done. It's not like they're going to be contaminated because they're finished. So all we have to do is, do the finishing, the wrapping, etc., etc. And the same thing for the output. Once the output is done, it has been cured. The contamination is not as critical as an example in a steel factory, when you have tons of material sitting on shelf and everything is susceptible to be contaminated because of the ambient dust. In an environment where you have 3D printing and high technology, the dust control is very, very efficient, and the quality of air is excellent, and the cross contamination is barely in barely not there. Now, of course, we're also, when we're talking about manufacturing, and I'm experiencing this right now in one of my facilities, is that we live in Florida. There's a lot of in and out, and the level of humidity right now is raining season, so the level of humidity is very high, and the temperature. So we have 90 and 100 degrees sometimes, and the humidity is super high because at night it rains and da 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 da. So we do have to have extra machine to have a better environment. But once you the setup is done, then everything else is easy to do. And we have like a series of dryers, and whenever we finish half of the production, we take our spool, our big 5 kilogram spool, we put them to dry, we take the other one, we swap them. So we always have filament that are drying, and then we swapping them back and forth after a few parts that are half a dozen parts that are manufactured. We're talking consistent size part, uh, and then just keeping sure, because I had too many clogs. I mean, every problems that you can imagine, I had them. So now I know what, and this is why I say you start with one machine, you try it at home. Maybe you don't want to become a manufacturer, and it's fine. But understanding the process, makes you an asset that is way more valuable than just somebody that give a drawing and said do this. Understanding how you transfer a drawing from a 3D model to a 3D model, understanding how you pick the right filament, understanding how you set up your machine, understanding your testing, because sometimes you don't want to go into a very long print and realize, well, no, that's not the color, or that's not the shape or the texture that I want. So you do a little sample, and then you take these samples and then you organize them, and then so that next time when you need to recall a sample, you pick it up. You said, oh, this is the preset I need to do. I need to adjust the speed. I need to adjust the heat. I need to adjust this and that, and you have it there. So you're building your own portfolio of of manufacturing, and also you're expanding your vocabulary so that you understand what's going on, what the machine reacts, what's going on in the shop, how everybody in the system works, so that you can have a consistent conversation with your team and tell them exactly what you think. Maybe it's the wrong why, and it's fine, but at least you are proactive. You're trying something, and maybe you can bring something that somebody else never thought about, or they are too tight, too close to the mountain. They too close to the forest. They don't see the tree. That being said, there is discrepancy. There is, and it's all possible. It is possible that two printer use the same files and produce two different realities. That is possible. But and that's why I say it's important to test, 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 test. For me, testing is one of the most important things. And when the reason why I test is because when I'll start to, and this is how my life is going right now. Every time I do a project, I build a series of tests from version 1 to version whatever, current version. And then I looked at, because I know that I'm going to have to produce a lot of them. And once I have something that I like, then I start to think about repeatability. And that's how it goes. So the process, the calibration, the documentation, the training, because my son works with me, and I have a couple technicians, and all those guys are part of the crew, and we're not working at the same time on the machine. So it's important that I have the proper documentation and that everybody does the same troubleshooting process, and the same, we go through the same training, so that the system is steady. Again, I'll repeat that for me, the file is not the product. The product is the whole system. And it's funny because today I was gluing a magnet on some parts, and that's the last process that I had to do, and I didn't think about that until today when I had to do it. Then my fingers became full of glue and this and that, and I didn't, like that was not part of my process. And I can be honest and tell you, but next time, right now I order some gloves, I order some Vaseline to clean my hand because it's petroleum based, and also I'm going to test the Vaseline. Maybe it will work, maybe it won't, but at least I'll have some solution. And now I have a full production line for that particular product. And it's the same thing for everything I do has lighting in it. So all the components, the power supplies, the LED, the drivers, the controllers, the power cable, the way that we're gonna hang it on the wall or stand on the table, and so forth. So it is important for me to understand the process, document everything, and the way I work, I have these production bins, and I keep everything about that project in that bin. Then I make a product list, and everybody has their own way of doing it. But like I said, I today was a wake up call. Now, what's the difference between $1,000 or $500 printer and a $5,000 or $25,000 printer? Of course, there's different in the resolution. There's difference in the reliability. There's difference in the component. There's difference in the memory, the heat dissipation, and the print orientation, and the size of the print, and the support structure, and the surface finish. All of that are there. And what the purpose of this video is that we are not there yet. Let's do baby steps. Let's start to take little product, little ideas. Let's start to go from something in your head to a physical product in the universe, and then try to make it better. And as you go, you may want to diversify your printing farm. You may want to partner with somebody else that has different machine. You may want to contact different manufacturers. And Friday, that is so funny. Yeah, Friday, what we'll do is because I thought today was Thursday and I put Wednesday, but it is Wednesday. So Friday, what we'll do is I promised you that last Friday, but I was out of town. We'll go around and I'll give you a bunch of resources so that you can start immediately without spending a big budget, without buying a machine, but without doing anything. You can start 3D printing very fast and start building your own ecosystem. So now the other component of all this, and this is why I'm here, is how do you share the love? How do you teach others? How do you make them understand what you're doing? Well, for me, I have a 10-year-old, and my son is very, very curious, and every time I'm onto a new project, I drag his butt in and I say, okay, listen, this is what we're doing, this is what we're doing. And he's learning by up nose, but also he comes up with his ideas. So I want to try to do this, and I want to try to do that, and we have a database of, I think, 5-6 terabyte of different 3D shapes, and shapes and animals and all kinds of stuff, lighting fixtures. So he has a whole um, uh, library of parts that he can do. And what I encourage him to do is that when we have downtime at the farm, to use the machine to do, and whatever's left as far as filament and different filament too, because I want him to experiment, to do different tests, create different batch, to have different problems, so that he can start to develop his own ecosystem, his own way of thinking, his own way of producing stuff. And eventually we'll get into metal and we'll get into more sophisticated print. But right now, this is not the point. The point is just try to push his basic, you know, um, his basic purpose a little higher, his basic knowledge into a more technical stuff. And of course, I have, well, I'm a lighting designer, and everything I do has to have a light. So on top of that, he has this layer, this connection with lighting, that he can think with himself. He can understand what optical do, because whenever I do tests, I try to show him instead of telling him, so that he develop his own way of thinking and his own language with light and his own consistency in product. So where do we start, right? I already started, and this is the whole purpose of this show, is that I just want to create that little spark that's going to help you to get up the chair and do something that you are 100% uncomfortable with, that you have 100% never did before, that you are 100% not sure if it's going to work, and push yourself through the basic. First, take your idea, put them on a drawing. Then try to find somebody with who, or if you have the capacity to use a software, there's plenty of them, and we'll go through those. Then start thinking about finishes, start thinking about color, start thinking about, if it's a lighting product, what kind of source you would like to do. Is it a general diffuse? Is it a directional? And if it's a general diffuse, what kind of material you're gonna use so that it diffuse the light, that it doesn't absorb it, and on and on and on. And for me, if I get you to get up your couch, or do something after work and do something that crazy, I think my job is done, and I'll be the most happy man, and I'm willing to listen and critique and work with you and help you and give you some ideas or reference and material. No matter what I can do to help, I will. And that's the whole point of it, is that I want to create this community of people that will help, that will understand what additive manufacturing as a solution for whatever project you're using. If you're making mock-ups, if you're making, like bathroom accessory, if you're making lighting fixture, if you're making ship parts, if you're making engines, if you're making whatever you want to do, there is something that you can tie into additive manufacturing and push yourself to learn something new. And I think in a non distant future, it will be a way of living. And in my utopic dream, this is my way of helping America to get better. We all talk about bringing more jobs and AI and all that stuff, but AI by itself is not going to do all the work, and it needs some human to be interfacing with them. And I think that additive manufacturing is a good way to get in smoothly, and also being in charge of the future and being in charge of your creativity and and your time. So thank you very much. Today was just the tip of the iceberg. We have so much to talk about, and have a beautiful day. And I'll see you tomorrow.